Hello everyone, welcome back to my channel. In this video I want to show you this new custom Dr. Stretch and Pull's Torture Factory. This is a custom building that I'm doing for a fan of mine, Flatline Racers. And so he is paying for this custom building here, so I took one of the regular Dr. Stretch and Pull's Torture Factories and I've added in a custom neon sign and the ability to shut off the motors optionally. This way it can hopefully add some longevity to the building. For anyone who hasn't seen, I've already done another set of videos showing my custom Dr. Stretch and Pull's Torture Factory, which is kind of what inspired this building. So it involves adding in NeoPixel lights to the neon sign. I still have not finished the programming on this new sign. It's going to be more complex and have more colors than my original sign. This is pretty easy to do though, that you just open up the bottom of the building with the screw plate, because this building actually has Phillips head screws that hold on the plate, and then the Arduino is underneath here, and you can just upload a new program to change the colors of the sign or patterns, flickering, not flickering, all this stuff. As you can see out here, we actually have some new red spotlights and an orange spotlight for the guillotine. And on the back side of the building, I added in some silicone wires attached to a dip switch set, so that you can have number one, turn on and off the regular running motors. These are the gears and the wheel in here. This one has its own motor, and then these are all on one motor. And then number two is the guillotine, which I'll just leave off. And then number three is the gate. And so the motors all operate just as they should originally when the switches are on. And can also make it nicer though if anyone has a layout that you can have the motors off and just have the lights of the building, and it's much quieter. And since the motors do eventually run down and break, it's just kind of inevitable and they take a lot of upkeep. It is nice to be able to shut them off, so you can only have them running when you're really looking at the building and really care about them going. So I'll go ahead and shut off the gate also. Just have the regular running motors right now. I want to show you underneath here some of the wiring that I've done. I am happy if anyone wants to send me a Limax building to repair or fix or customize. Let me know in the comment section, or you can also contact me with my about info on YouTube. Because YouTube sometimes flags comments if you're trying to reach out, so just let me know really with my about info. I have my email and phone number posted there. And I'll go ahead and shut off the building just for safety. But here is the Arduino, and for anyone who doesn't know, NeoPixels require 3 wires to operate: a data, a power, and a ground wire. So power and ground are going to the Arduino, and the Arduino and the NeoPixels I used are operating off 5 volts. The Limax buildings use 4.5 volts usually, so that's close enough to get this to run, and I haven't had issues with it sucking too much power. These other wires that are here, they're going to the added outer lights. So, and then I also added in a diode, and the reason why is from positive power coming from the board to the Arduino, you want to make sure you don't have any backfeeding power going back if you plug in a USB cable, because the Arduino, again, since it's 5 volt and these are supposed to have 4.5, I don't want to risk just that even half a volt different. So just in case, I added that in. I'm not really sure if anything would happen. I haven't tried if something would happen, but basically there's a diode though going in between the Limax and the power wire here, so the diode's underneath this tape. The reason why I used masking tape is it seems like the glue holds a bit longer. Sometimes electrical tape ends up just being slimy after years and comes off. So you can also use shrink tubing, whatever works. As far as getting power, using a voltmeter, you can usually tell. The Limax boards, depending on your building and age, the earlier 2000s boards usually had a ground strip going around the whole board, and then it has power in the middle, and then different circuits branching off in between power and ground. And so your main IC chip is right here, that brown board that's doing the sounds and stuff, and then it controls other circuits going in. So tacking ground for the Arduino, I just tacked a ground wire onto the ground rail that's going around the outside. And then the positive power, like I say, it's this, the middle positive rail that goes through the board that supplies a lot of the circuits branching off. So that's how I got my power and ground. And then I'll try and point out the motor connections on this building. If you're looking at the board the same way that I am, first off, up here on the very top, at least for mine, the regular running motors, which are the gears and the guy on the turntable in here, is up on this corner, and it's attached with 2 orange wires. And these buildings are always a mess. So you can see the 2 orange wires. You'll have to trace these a bit, like try and look into the building, see if you can figure out where they're coming from just to make sure. But basically, these orange wires could be tacked on technically anywhere on this outer ground rail, so you just have to be careful on your specific building, since these are kind of hand soldered, I think, in the earlier days, or I don't really know how they assembled them, but there is some differences in wire color I've noticed, and even board color. So the circuit overall should be the same, like the board layout, but the wire colors may vary, so just be aware of that. Basically, I just separated the 2 grounds for those motors and put them on this wire. So basically, those switches that I showed you, the dip switches in the back, basically just form a loop where it takes the solder point from the board, loops it over there, and then comes back and attaches onto whatever wire I just connected. So this way you can switch it on and it'll connect the normally what would be soldered wires, or disconnects them. And using the silicone wires is very flexible, so then you can move the board around. These are 26 gauge wire. I ordered these on Amazon. So 26 AWG. You could probably go with something smaller, but I wasn't really sure what would work. These seem to be fine though. So that's your ground for those motors. Then looking over here, there is this blue and white wire set. And basically this white wire I desoldered from the board, and it's attached to the silicone wire. Here's where it was attached to the board. It forms a T right here. If you look closely at the traces on the PCB, it makes a T kind of shape, and then it goes back. and then the blue wire goes in above it. So you could technically disconnect either one of these that you want. There's where the blue wire solders in. So you basically have 1 and 2. The reason why I had to do 3 separate dip switches is because for the blue and white pair and the black pair, where even is that one? There's the black wire. It's a black and orange set, actually. This one here. For the guillotine motor and for the gate, since the motors go up and down, it actually has to flip the polarity of positive and negative to get the motor to go up and then down. It's 2 separate polarities, and it actually disconnects the motor for it to stop. So it has positive, negative, get it to move, and then it halts, and then reverses polarity and halts. So for those, they have to be separate. So that's why you have to do separate switches for those motors. So basically on these different traces up here are the actual polarity flippers. So they have like another separate T going the opposite way for the blue wire. I just decided to disconnect the white wire because of it was easier to resolder here. So white wire going out and to the switch and then returning, and just soldered onto that white wire. Again, I don't know if you're building, it might be a different color depending on the year or whatever. Also, I do know for a fact that the later models of Dr. Stretch and Pulls will not have a guillotine motor. So if you do not have this unit in here with the little string and your guillotine is stationary, you don't have one, and you don't need to worry about this next motor. And there's a chance, I have not actually owned or worked on one of the newer ones that doesn't have a guillotine motor. There's a chance that your computer board still actually has everything soldered onto it. I'd say more than likely it does. And if you were savvy enough, you could probably rig a working guillotine up, but I don't know if that's worth your time. That's something you could fool with, but anyway, that's where it connects onto, though, is right here. It's another T below the first one. So looking at it, it's kind of easy to figure out because as far as I can tell, those are the only T looking traces on this board going this direction. So yeah, it's the first one up is the guillotine and then the gate motor. So disconnecting the gate motor, guillotine, just loop back, and that's how I did it. This building, as far as doing the lighting goes, is tricky and not for the faint of heart. Doing these is easy. If anyone is just decent at soldering, you could pull this off. I think I had like a 600 ohm resistor or something in between the reds and the positive power. I recommend just figuring out what resistor you want to use by just getting out higher ohms first, seeing if it'll light up, and getting your brightness correct. You cannot have it too bright. If it looks like it's really, really bright, definitely get a higher resistor, because then you're going to burn out your LEDs sooner. By having it dim, then they'll last much longer. I don't know if there's anything else I need to mention. As far as getting the NeoPixels in there, these that have electrical tape on top are the original LEDs from the sign. I did not want to cut them out. You could do that if you don't want them anymore, but I left them in here. So there's the set of blinkers and the regular on LED. These suck for trying to light the sign. They were too dim to begin with. If you wanted, I could definitely even rig up a mimic sign that you could even program it to look like original, but it would still be much brighter. Because it's a bit hard for the camera to tell, but I mean, this sign is much brighter than original in the first place. And then I also added in another pixel behind here, so depending on the pattern, that one behind the sign will light up. So there's the other one. So you can even have alternating colors now, and there's the new LEDs located behind there. On my original building, I actually tore out the rotating table guy and actually had this whole motor unit out in order to do those lights. And that is a bit nerve-wracking, actually tearing this out, and you might break stuff, and it can get messy. What I was able to do, though, is with needle nose pliers, go in there and rip out the original ones, which are held in with hot glue. And then I had a pair of curved needle nose pliers. Let me see if I can find them. Get there. Here we go. Just a giant pair of needle nose pliers. These are not the most pretty looking tools, I'd say, but basically the problem is getting those fiber optic bits that are up in there for that sign and getting it to stay put while you try and glue in the new ones. And so what I did is I very carefully maneuvered this up in this side because you have a bit more room. And so I went up inside of the building and grabbed on and then put a pair of vice grips onto this to pinch it. And then with the weight of that, it was able to stay put while I went in on the other end and fed in the new pixel LEDs. I just used some of this pixel LED strip. It's WS2812B, and it's pretty much the smallest spacing you can get. I think it's like 90 LEDs a meter. So you just go ahead and cut. The arrows indicate the path of data flow because the pin in the middle is data in, and then it's data out and data in between each LED. On the original one, I kind of custom soldered some WS2812B LEDs up. For this, though, I used these, and the spacing was good enough that it was able to work. For the one in here, I used a bigger LED because I could, and it's easier to solder. And then, actually what I did is I fed this one up and fed the wires back down, and then soldered, because how pixel LEDs work is they need a daisy chain, so you have data in, data out, data in, so on and so forth. So the data out from the fiber optic LEDs goes to the data in of the one behind the sign, so they can do chaining effects of having this one, that one, and having it all look nice. So I fed the wires from this down, soldered it onto those LEDs, and then fed them up. It's I was impressed. I was able to pull it off, and it would be very tricky, I think, for most people to do. And if anyone wants me to do this on their building, it's possible, but I don't even know if I could guarantee being able to pull it off multiple times. It was very tricky. And then after I got the LEDs up here, I was able to stick in my hot glue gun right through this opening like this, and basically have the building laid on its back so that it would fall onto it was very kind of a feat of engineering. I don't know if it's possible to do again. I could attempt it, but it's very tricky to do without removing stuff. If people just wanted me to remove stuff or they needed it repaired, that's different. I'd say it's almost easier to do, but on my original building that I did break stuff. Like mine, I did actually remove these figures, and I accidentally broke the tower on my building because I didn't realize that having it on its back wasn't even safe. On this one, I actually have it laying on a sponge so that you don't put any pressure onto the tower because of this one broke off. It's a lot of little things. So this one, I mean, knock on wood, I can actually get it 100% back together and closed up and nothing will break. So far so good though, that nothing is actually broken. So you just have to be very careful though when you're working with this. Don't force anything. The wires get caught up on lots of stuff inside of the building, and feeding it back in, you just want to be careful and work slow and just make sure you feed all your wires back up inside, and you should be good to go. Yes, I think that pretty much sums it up. I'm gonna leave the Arduino facing downward like this, but up a bit higher, and then you can program by just inserting in your USB. So if you just open up the little shield on the back, the plate with the Phillips head screws, you can just reprogram it if you decide you want to change the neon signs effects. And of course it'd be possible, if anyone really wanted me to make a completely custom building. If for some reason you liked a certain Lemax building and you hated the soundtrack and you wanted the motors to do something, like, I could make a completely custom building to your design. I will charge obviously for my time and materials, so keep that in mind if you're wanting building done, that it will it does add up the more stuff that you're wanting. This particular building, I'd say for my time and materials, all that stuff, is about 200, a little bit less. So I mean, Lemax buildings do cost a lot, and if you have a building that you love, like Last House on the Left, or I don't know, it would depend obviously if it was really worth it to you, it's sentimental or something, or you really wanted new light effects, which is totally unique and superior to the majority of ones that you'll find. So anyway, thank you for watching. Hopefully this gives you some ideas if you're an electrical engineer like I am and you want to try something new with your building and trying to revive them or whatever. So thank you for watching, and stay tuned for more videos on my channel.